Okay, it's time to start the session. Fast prototype with Flutter and Kotlin native. Please give a warm welcome to JB Lorenzo.
Thank you, Ken. Konnichiwa. I'm JB, and I'm pleased to have you here. And I'm going to talk about fast prototypes with Flutter and Kotlin Native. Kotlin Native is one variant of Kotlin multi-platform, which allows you to compile your Kotlin code into something that you can use on iOS. So in this talk, I'm going to focus on iOS and Android only, and not the other platforms of Kotlin multi-platform. So who here uses Flutter? Raise of hands. Thank you. It's a lot of people. And who uses Kotlin? Everyone. Thank you. So yeah, basically, one of the reasons why we use this approach is that almost everyone knows how to do Kotlin, and not a lot of people yet knows how to use Flutter. And this is like a transition stage. If we want to fully move to Flutter, we can keep the existing Kotlin code that we have and use it in Flutter. So first, I'll start with the story of why we came to this approach. So I work for OLX. OLX is a classifieds app similar to Mercari. And OLX planned a tech conference last year in September. And my manager got news from our VP that we will do the conference app because the previous conference app was made by a third party and it wasn't so good. So yay. Who doesn't want to impress their bosses, right? And pressure as well. So our team, together with some colleagues, started the effort to make the app. So after the story, I'm going to talk about the implementation and some of the notes that we discovered along the way. So this is not just a story, don't worry. So this is the team. We have 3 mobile developers, 2 managers, 1 UX or product person, and we have a lot of real work. So we could not set aside time for this, just to work on this and take time from our ordinary work. So really had to save a lot of time in order to get this done. And also we had to impress our bosses, right? So we have around 1 month since we were informed that we need to make this conference app. And for those 1 month, we need 2 weeks for testing and feedback from the organizers. So we had around 2 weeks of real work that was left to us. So what we thought about was we were planning, and we thought we needed to do cross-platform development to save a lot of time, and also to use existing backends such as Firebase, which we did use. So the initial planning came out like this. So we wanted to use Firebase for backend, and for the logic code, we wanted to use Kotlin native. And then for UI, similar to DroidKaigi, we thought of using material components for both Android and iOS. This plan seems easy and seems like it would work, but then we had some problems. I would not go into detail what kind of problems we encountered, but it was with material components. It was last year in September, so I'm not sure if it was ready for production back then. And we couldn't get it to work with Kotlin native and Firebase. And we thought it was too risky to push through this kind of structure or architecture for the conference app. So we thought, why not use Flutter? And also with this approach with material components, we had to write the code for iOS, the UI code for iOS. So you have to do the UI code twice, once for Android, once for iOS. So after the planning, we realized that we wanted to do Kotlin native, Firebase, and Flutter. And then afterwards, we got some designs from our designer, which was Karen, the girl at the bottom. She used material theming plugin from Sketch to generate this design. She did this in almost one sitting. She just sat there, and afterwards she stand up and it was finished. We were surprised. All of this was finished in one sitting. and then we had some feedbacks, but just minor improvements to this. But basically, this was really good. Also aligned to our brand guidelines, the colors was right for us, and we wanted the app to look exactly like this, and not compromise on anything. So with this, we have the plan, the architecture, and the design. So now, why did we push through with the Flutter and Kotlin native architecture then? So I'm going to discuss that. And once you convince yourselves that you want to try this out, also if it's depends on your use case, if it's right for you, and then how to set it up. I've updated the setup steps. Back then, it was different. Kotlin native was an older version, and now it is updated. I tried compiling it the other day, and it didn't compile, so I had to update it. And I also updated the slides. And also, after setting up Flutter and Kotlin native together, you have to learn how to communicate Flutter with Kotlin. So this is achieved using method channels, which I will discuss later. And what are some of the pitfalls that we learned while we were doing this? So why this approach? We tried to minimize as much as possible the platform-specific code. So we want the common code, which is the logic, which is fetching data and parsing, and all the preparation before presenting the data to be in our Kotlin native layer. And then we wanted all the UI parts to be Flutter, because we knew that Flutter can handle this. And we wanted as little as possible code to be platform-specific. So the Android-specific code written in Kotlin and iOS-specific code written in Swift, we wanted to minimize them. So this is the architecture that we worked with. Once you convince yourselves that you want to try this out, how do you start setting this up? So what kind of project structure works? Let's take a look at the project structure from Flutter. When you start with Flutter, you get these files and folders built for you. You have the Android folder, you have the iOS folder, and you have other lib folder where your Dart files are, and you have the pub spec files where your dependencies and other declarations are for Flutter. And so this was already built for you when you start. So how do you add Kotlin native to this one? Let's take a look at Kotlin native's structure. It's a bit similar. You also have an Android folder. You have an iOS folder as well. But you have a JVM folder, which is for other platforms. We're not going to use that. And also you have the common folder. For Kotlin native, you can name it whatever you want, but you have a module, basically, that will be used by all your by both your platforms, so Android, iOS, or whatever platforms you want. So you also have a bunch of Gradle files there, and we want to combine them. So this is the result of that, and we're going to go through file by file and explain how we did it. So first we'll go through Android settings.gradle file, and this is what it looks like. So there's a bunch of lines here. It's hard to explain, so I'm going to explain line by line. First, this part was already generated by Flutter. What it does is it adds the plugins that you add to Flutter to your settings.gradle file. So if you, for example, added Google Sign-In as a plugin for Flutter, this part handles it for you so that your project can see it, your Android project can see it. And then you want to add the app module and the common module that you have so that your Gradle can see it. And then the common module, you want to define where it is, because as you know, currently we are in the Android folder for the settings.gradle file. So you want to point it outside, up, one directory up, and then the common folder. And then, of course, for Kotlin multi-platform, you have to enable the Gradle metadata. So that was Android settings.gradle file. And we now go to the second one, which is the build.gradle file for Android. So basically what you want to do here is just to set the version of Kotlin, which is 1.3.0, which is what we used. And then just add the Kotlin Gradle plugin for Kotlin. It's basically just setting up Kotlin for your Android project. So that was build.gradle file. And then we're moving to the app Build Gradle file. Basically, just want to add the common module where your Kotlin multi-platform shared code is to your Android project. So this is very simple, not so much lines. So that was the Android part. So we can now move to the common code, which is the build.gradle. This is a larger file, which will be continued on the next slide. But basically, this first half just defines the targets that your Kotlin multi-platform module will generate. One target is iOS, which outputs a framework, and one target is JVM, which we will name Android. This is you can get this from documentation in Kotlin, so I didn't highlight line by line. Basically, you can just copy there. But one limitation here that you will notice is the iOS part is only 64-bit. So if you want to run your app on devices that are 32-bit, which is, I think, iPhone 5S and below, you will have to define the 32-bit version here as well. We didn't use this because back then we couldn't find a way to add the ARM32 support, but now they have it, but I didn't update it yet to support both architectures. So this can be left as an exercise to you viewers. So the bottom half just says you want the standard library from Kotlin. If you want to learn more about the standard library of Kotlin, you can watch the video called Dissecting stdlib. It's really good from Kotlin Conf. It really goes deep into the details of what it does. So the next half of this file is to set up the iOS compilation code. So this is the same file, but we're just defining a task for you to run in your iOS part so that it updates the framework that you're generating. Not going line by line, but basically that's what it does. It's also in the Kotlin documentation. So that's your common module, and then we can go to the iOS part, which is the Xcode project. I'm not sure how many of you here knows iOS, so I'm not going into details. But you want to put the script in your build phases. Basically, it's like the Gradle tasks. It's executed one by one. And when you put this line, you are just saying to Xcode that you want to switch to this folder where the framework lives, and then there is a Gradle W executable there, and update the framework. So whatever change you make from your Kotlin native files, it will be regenerated as a framework when you compile the iOS part. So some screenshots from the Xcode project. You need to add the framework that you generate, of course. It doesn't, Gradle doesn't add this for you automatically. Just drag the framework file and make sure it's embedded in your project, in your embedded binaries. And then make sure that your Xcode project can find it in the framework search paths. So just add it to the path below there. Now we've set up the files that we need. At this point, we have Flutter and Kotlin native working together. So you can now use them both in your project. But at this point, how do you use it? So we need a way to glue Flutter and Kotlin together. So we can achieve this by using method channels. Method channels is a interface provided by Flutter that you can communicate from Flutter and your native code, either Kotlin or iOS, Kotlin or Swift or Objective-C, and vice versa. So you can also go from platform-specific code going into Flutter. So this is a two-way channel. So for Android, this is simply just to set up the channel. The all caps channel there is a string, which is the name of the channel. Pass the Flutter view, and then set a handler. When you pass a string to your Flutter code into the channel, it gets inside this method, if it's the same channel, and then you can process the method. So here you have a switch case where the method name, if you pass a method in the channel called method name, you can call this method called do something with. And then the do something with can come from the common module, which you wrote for Kotlin native. It's called Kotlin multi-platform. So in this way, you are communicating between Flutter and your shared Kotlin multi-platform code already. You can also do the other way, but I didn't show it here. But that side is from Flutter. Same with Android is the iOS part, where you do the same thing, set up the method channel, but in this part, you have to import the framework that you have generated. And then you can call it in the method handler as well. So if you pass a method from Flutter, let's say get battery level, which is something you cannot do in Flutter, and you need to do in your platform-specific code, you can process it here, get the method name, and then execute your command, which can come from the framework that was generated from Kotlin native. And then we encountered some stuff while doing this. So we're going to share the learnings with you. As you noticed, we're calling into a channel, method channel, and you cannot pass a whole class there from Flutter. For example, you have defined a custom class, and you want to pass that whole thing into your Kotlin multi-platform code. It's not easily done. It's not easily done. What you can do is you have to serialize it. You have to make it a map, which the method channel supports, and then go through the channel, pass it through the channel, and at the other side of the channel, you can deserialize it into a class in your Kotlin multi-platform code. But you can also work with maps or hash maps, whichever you prefer. But this is something you have to remember when you're working with this. Also, if you define a static method in Kotlin, you get it on the Swift side as a separate class. It doesn't appear as a static class when you compile it. It's a totally different class with a different name. So you just have to remember, if you're calling this static method from Swift, to call the new class name and then that method. And then something that I've mentioned earlier is ARM32. You have to remember to set it up, because the sample code from Kotlin native only gives you the 64-bit version. You want to do this if your audience is large and you will expect them to have older devices. And also, there is no bitcode support for Kotlin multi-platform. You have to turn it off. And this is not a big problem, but if you want the advantages of bitcode, you cannot use it right now with Kotlin multi-platform. And of course, something that might be a deal breaker for some of you is if you modify something from the Kotlin multi-platform code, there's no hot reload. If you save it and you try to manually hot reload Flutter, it will not load the changes. You have to recompile the whole thing and then run it again. But you will get the changes after you do this. But if you do some changes in the Flutter side, of course, it will reload with hot reload. And of course, with JVM libraries in Kotlin multi-platform, you cannot use them because, for example, if you're using URL, java.net.url, you cannot use this in Kotlin multi-platform, and you have to use something else. And those are the pitfalls. So I'm going to show the result. This is a video. It's kind of boring, right? So I'm going to show a live one. So this is the conference app that we did. Looks pretty much the same as the designs. Not sure if it's big enough. Can't seem to enter. So this looks exactly the same, or not really The title bar in Flutter is on the left for Android. And you can favorite stuff. And goes to the favorites. My face is here somewhere. Here. And then what we want to show, if I still have time, I have a lot of time, is to show some changes. So from the Kotlin multi-platform layer, what we want to do is make a small change and see it reflect on both iOS and Android. So we're only modifying I'm pretty sure you cannot see this. We're only modifying the Kotlin file. And what we want is to see changes, again, in both Android and iOS. So we have here the parser for the data. And we have the room. So what I want is just to add something like DroidKaigi before the room name. And again, we have to recompile because it doesn't support hot reload. So what we expect is from here, the room names. You can see that, right? From the room names, it will have DroidKaigi in front, also with the Android one. Not sure how long it will take to compile. There. And also iOS. It's not done. Come on. There. So the Android part has already gotten the changes from the Kotlin multi-platform layer. Every room now has a DroidKaigi prefix. And then for iOS, we're just waiting for it to finish compiling. So this shows that you can make changes on your Kotlin multi-platform layer, and it will apply on both Android and iOS. This is also something you can do with Flutter, since it's also compiling for both. But as I asked earlier, a lot more people know Kotlin right now. And it's also, for us, a personal preference that we have language features present in Kotlin that are not present in Flutter's language called Dart. So in Kotlin, you have null safety. A compiler checks for you if you are handling your nulls properly. But in Dart, you have to do it manually like in Java, like a caveman. So, sorry for Java users. So here you have there. So the small change that we did here, only from the Kotlin file, was obtained by both Android and iOS. That's basically what I wanted to show. So going back. These are some of the takeaways. Not really very informative, but I'll go through them. So Flutter is awesome for fast prototypes. You can start with Flutter. I'm not forcing you to do this approach. We started with this approach, as you remember, because we started already with Kotlin native code. And then we had some problems, and we had to transition away from material components and replace it with something else. But Flutter is awesome for fast prototypes. And then if you decide later on that you want to replace Flutter with something, you have a choice. Since your logic is kept in Kotlin multi-platform, if someone, probably someone here, makes a library for Kotlin multi-platform that does the UI itself, you can replace it with much less effort than replacing the whole thing written in Flutter. And also, we use this while Kotlin native is in beta, still in beta, but it's usable already. And Flutter was in beta back then, but we also used it. We were a bit brave, but yeah, especially when the users of our conference app will be the bosses, and it'll be scary if something goes wrong. And Kotlin native works well to reduce the amount of platform-specific code. Kotlin native also has this way of writing the platform-specific code where you expect the method to be implemented. So you have something like an interface written in Kotlin, and that's what you work with, which you can further reduce the amount of iOS code that you write. Who likes iOS, right? And now Japan likes iPhones. And of course, you need some glue code to write. Need to write some glue code to pass around from Flutter and Kotlin native and vice versa. You can also just write a plugin for Flutter and wrap your Kotlin code or Kotlin native code in there. And of course, don't be afraid to try out new technologies like us. We were new with Flutter and Kotlin native at that time, but we had a need to reduce the amount of effort for our conference app, and it was a success for us. So it was good. There's some talks. The next one is from Sally, also from Berlin. You can check it out. It's also in this room, animations in Flutter. And then these are some Flutter talks that I saw. I really wanted to attend this one, but it's not in English and there's no interpretation. So I'll probably just check out the slides. And then there's also code sharing between Android and iOS with Rust, which I didn't see because I was attending a different talk. And then there's also some Flutter-related stuff. Again, the animations in Flutter is next. Just so you don't forget. And please, if you have time, check out our tech blog. And my Twitter handle is there. I still have a lot of time, I think. But that's it. Thank you very much.